All right, let's begin. Hello, and welcome to the IPFS weekly call, where we get to learn about the amazing stuff that is being built on top of IPFS. Today, we're going to hear from Brendan, who is the CEO of QRI. That is being built on top. And QRI is a peer-to-peer tool which helps people deal and handle and share data. So, Brendan, I'm going to let you take it away.
Amazing. Thank you, Portia. Thanks, everybody, for coming out to a weekly call. So as Portia mentioned, I work at Query, and we're trying to do data science in a new way. We think that we like to call the thing we're building the data bazaar, which is very similar to like the data, or we use the sort of software metaphor of like we have the cathedral style of building software and the bazaar style of building software, which is sort of like the origins of open source. Cathedral style you can think of as like many of the like wonderful closed teams that are mainly working in a tight knit group, and then the sort of bazaar style where it's very much just like take any comers. If you're coming around and you want to sort of contribute what you can, do it. And so our theory of the way the world works right now is that there actually isn't a data bazaar. And the reason for that is because there's a number of underlying technologies that are missing that IPFS really helps provide a super solid foundation for. And so when we mean data bazaar, we're looking for some very key characteristics. We want to see something where it's a two-way conversation, where anybody can sort of like give and take whatever data they want, where that conversation is meaningful. So it's sort of structured in a way that everybody can sort of understand what everyone's talking about. I think if you've ever worked with GitHub or any of the sort of like open source collaboration tools, you have a feeling for what this means. You sort of know, like, I'm going to create a pull request, and a pull request is a request for someone to change the way your code works, and that code, there's a process for auditing that. And then finally, you just need this capacity to attribute all of these changes back to the people who made them, so that as you're collaborating, you have this sort of like audit trail. And this is what we get a lot from the sort of whole world of version control in software. Unfortunately, when you go from software to data, things change a lot. And software is not data; they're not interchangeable things. And the biggest thing that changes is volume, right? So if you think about your average GitHub repository, it rarely exceeds a gigabyte of space, even with this entire history and sort of like this whole thing, unless you're developing Ethereum, but that's a whole other conversation. But the sort of like when you move over to the data space, like a gig is very normal, right? And versioning is a much different conversation when you're versioning data, because often you're taking a single file and you're making individual changes to a single file. So imagine your massive CSV file with lots and lots of stuff in it, and you're just making small edits to that. You need to be able to collaborate on it. And so if we zoom out for a second and we think about IPFS and what IPFS is, a lot of the things that IPFS does are actually like a perfect starting point for building a dataset version control system, which is what Query is. If you think about an IPFS hash, that is a bunch of files broken up into blocks. We're specifically referring to Unix FX v1 hashes as a reference point for anybody who's playing with IPLD versus not IPLD land. But it's a file system, and under the hood, all of those files are being broken up into blocks. And so with Query, we've designed something that is intended to start from the primitive of IPFS, not that IPFS is primitive, but using that as a foundation, and sort of build upwards into a system that allows you to do convenient and structured and reasonable and rational versioning. And so today, I'd like to just sort of give, some of you on the call are already aware of sort of what Query is, and we've sort of met and chatted a bunch, but we've made some pretty major progress since the last little while, in the last sort of number of months. And so today I'd like to just show you some of like what's been happening, and feel free to sort of just like put your hand up and ask questions at any point if you sort of want to stop me and sort of see what's going on. But we'll sort of give you a like high level tour. For today, I thought it would be fun to prep something that is a data set that is more relevant to the sort of IPFS community. And so how many folks have ever wondered just like how many nodes are online at any given point? Yes, yes, yes. Okay, cool. Yeah. So today, let me just sort of start with, I'm going to share my screen. I'm just going to share my whole desktop, and hopefully my desktop is not too muddy. All right, that's straight to code land. That wasn't smart. Cool. So here is an answer to your question. If we sort of like zoom in on, when was this? Monday, June 10th. So if we count the unique number of peers by hour, there are 3,446, and then I have to move this window, I'm sorry. And there were, if we look at it over the last day, there were 6,000 unique peers seen over the last day. And so what you're looking at is a visualization of a query data set. And so this is sort of the overview of a data set. And we think about this very similar to like a GitHub repo, but our notion of a data set is far more granular than a repo. You would have many data sets, many more than you would GitHub repos. But the thing that's really important about query is it's a very structured conversation. So I've just shown you a visualization. Oh, cool. We did great. Oh yeah, I have to run this in the background. Shh. Demo gods aren't being nice to me today, but actually this is a demonstration of connecting to the distributed web. And at the same time, it also serves up for me a local host of my data set. But if we look at the thing that's most important about query is like to try and normalize this conversation around data. And the way we've done this is we've developed a data set document model where everything is structured the exact same way when we're talking about data sets. The actual contents of a data set. So like if we think about like the CSV file in a data set, we call that the body. And we're sort of working very similar to the way that HTML documents work. All of our metadata is stored in something called meta, and then meta and structure and transform sort of collectively are referred to as the head. But this is the actual data. So if at any given point, you can literally just pull this hash off of IPFS, and we'll let this load in the background while we sort of resolve that. I could resolve that locally. But anyways, the data itself is actually right there and always accessible to you. So at any given point, you can go to this hash / body.csv and you will see this data. Actually, in this case, I think it's a JSON data set. Yeah, this is in JSON, so it would be body.json. But we sort of get what we need to sort of start this data bazaar conversation. I have created this data set and it has a recurring history of changes over time. And each one of these is built exactly the way that Git is built, where each snapshot, each data set is a snapshot that references its prior one. So this is the initial one, and then sort of moving up forward as we make all of these changes. And every single change is tracked and every single change is attributed. And all of this is every single time we're sort of writing this down as an IPFS hash and moving that around as we need. But we've all, oh, sorry, I have a chat thing. Give me 1 second. I have to, is there sports? Let's do something. Is there live support for live data sets? As of right now, we sort of think of that as a separate set of concerns. Eventually, we'll get into the sort of pub/sub sort of live distribution of stuff. But there's a real sort of, one of our big primitives is we are very snapshot based right now. So the short answer is no, there's no support for anything sort of live. But I think that's a great point to sort of start this conversation. We have to sort of deal with the problem of keeping this data current, right? And so we kind of have two options in this very concrete use case. Like what this data set is doing under the hood to sort of get into the details of it is this, each data set comes with something called a transform script. And so we've embedded a programming syntax into query called Starlark that looks a lot like Python. And so I can actually pull this open in an editor, so it's a little easier to see. And so you can actually write Python code that explains to a data set how to update itself, which is a very useful tool because we've now bound that transformation script to the data set itself, and it moves around with the data set. So if you add this to your query node and this moves from one peer to another, you have the majority of the details you need to recreate that data set, and you get your own update button to rerun this. But then in this special case, we have this sort of like sticky problem of like, Starlark doesn't know anything about it. So we have to like deal with some of these sandboxing issues. And most importantly, there's the way that we're actually grabbing these metrics is we are running a Kubernetes box in the cloud that is scraping the IPFS DHT. And so there's a sort of an intrinsic problem here where everybody could do that, but that would be, if we had like 1,000 people sort of clone that data set and run these DHT scrapers, that's not really gonna help our DHT stay healthy. And if it is, it's just like a lot of access requests that we're all having to serve. And it would probably be smarter if we set this up and ran it and had it sort of scheduled to automatically update. And so that's sort of what we've built at Query most recently is we're calling it a fog service because we think it's, I don't know, it feels like a fog service. And so what this means is if I do query update list, hopefully you can see this and make this a little larger. And I'm gonna wait for my computer to figure that out. Okay, cool. If I do query update list, this is a list of data sets that are scheduled to automatically update. So I can see that the third item here says that in 23 hours, I'm going to rerun this shell script. And if we look at this shell script, where is that shell script? Let's find it. 1 second here. IPFS node count. So this is the shell script under the hood. And so what this is doing is this is running on my computer. And this is something that Query is scheduled through a daemonized process registered with my operating system to reach into my machine, connect to Kubernetes over a set of secure keys that I control and don't have to distribute with the data set. We run a proxy connection to a Prometheus instance, which is going to provide us with data. We're going to wait for that connection to sort of occur. And then we're going to actually we're going to run the transform script that depends on that server running at localhost 9090 as if there's a Prometheus instance that I can access that's running this data. And that's going to update the data set itself. And that will then publish, because I've included this publish flag, this will then automatically push that data set up to Query's cloud backup. And so we run something called a registry, which keeps all of your IPFS hashes of data sets live on the distributed web. And so every 24 hours, this is going to run. And so every 24 hours, we'll get new data being pushed. And so all you have to do if you want to get this data is follow this data set, which is B5 IPFS node count. And you just hit update, and you're going to get new versions of data and the new stuff that you need to do your analysis. And so this is what we mean by sort of a data bazaar. You can take this data and do whatever you want with it, do whatever you think is useful or relevant with it, but it's structured in a way such that you have an audit trail. And so you can actually see how this is working. And if I've done my job correctly, I've annotated everything. I've included metadata that lets you figure out what's going on and how this is working. I've sort of included some comments in the transform script about what GitHub repo we're running to sort of achieve these stats and how this is working. And you can sort of decide for yourself whether this is sort of worth investigating. I'm going to turn to the chat really quick. Okay, amazing. Yes, okay, good commentary on fog service versus cloud service. But yeah, we could totally talk about fog and mist and other particles of water. I'm into all of those. But the point being, like, we also include these visualizations just to make everything sort of a quick and easy, and this will just update itself every time. The last thing I should note is that maybe I can access this locally. Localhost. We also make the gateway available also. I should do that on 8080. I always get that wrong. That second slash is really a nightmare for me. Or is it 5001? Pardon me. So if we actually look at this is the actual contents of the data set itself. And so you can actually see every single one of these snapshots is a individual thingy with references to their root hashes. This is how we do comparison work. Yeah, there's a lot going on here. I should probably stop for questions. But last but not least, we do actually make, we've done a bunch of work to like make sure that we're sort of fully interoperable with the existing sort of IPFS ecosystem. So when you're running Query Connect, which is our version of IPFS daemon, you can actually get to the web UI. And this is kind of fun that you can actually see the version of the thing registered properly. And it's like fully there and ready to roll. We can explore our files and stuff. And so this is all thanks to the wonderful work happening, particularly inside of Go IPFS to sort of make this really easy for us to sort of bolt in. And so, yeah, maybe I'll stop there for questions and see what's going on and read this chat.
If you like, you can take the presentation to the end and we'll have questions afterwards.
Okay, cool. Yeah, and then I guess in terms of presentation details, it's easier to talk through some of this stuff. So we've, yeah, over the sort of like course of getting this up and rolling, we've been, this sort of next couple of months are going to be an exciting time at Query. We finally passed a very important milestone for us, which is the sort of back-end features of building and managing a version control system are far more fleshed out than they've ever been. We have a lot of work to do on documentation. We have a lot of work to do on tutorial writing. And then we have a very, very, very big overhaul to our user experience front-end side coming. But we're very happy with where the backend's at. Now that we have this capacity to auto-update and auto-publish, we think that it forms a really exciting sort of system where people can be designing these data sets on their own, and they are their own source of authority on what that data is, and are now able to publish that sort of automatically. And ideally, this is sort of helping us get around this, like the two nasty problems in data, which is auditability and keeping things fresh. And so we think of this as like one giant sort of like data bazaar of stuff that you can get access to. Yeah, is there a public registry of all the data sets that people publish and maintain? There absolutely is a public registry of all data sets people publish and maintain. It's registry.query.io. Thank you for the wonderful question, David. And so it is worth digging in a little bit for this crowd into what the registry is for us. A registry is, we maintain two things there, which is just we enforce unique peer names there. So you can see my peer name is B5. And so that is actually negotiated with the registry, which is a centralized system in relation to a decentralized system. It also handles search for us. If you run query search, that's going to the registry. We're working on distributed search, but that's obviously like a very experimental part of the neck of the woods. And finally, what it does is the registry, if you sort of think about this as a parallel to what GitHub just recently launched in terms of their repo availability, our registry is just a backing layer for the distributed system. So all we're dealing with in the query registry is we're just keeping hashes available so that when you close your laptop, that hash that you published is automatically there. And so it looks a lot more like the GitHub system, where GitHub is sort of just hosting your Git repository. This is very similar to what query is doing. It's just hosting a copy of your hashes. Query registry has no capacity to publish anything on your behalf. All commits are signed with a special key pair that is provisioned according to every user's query node. It's different from your IPFS peer ID, mainly so that you can have many IPFS machines and use the same profile. But is there a concept of forking? Yes, forking is just like the de facto way that things work. If you run query add on somebody else's data set and then you edit that data set, it forks. And so now it's just your own. And that automatically is sort of set up for you. We haven't figured out the merge. We know technically how we're going to do like pull requests, but we haven't actually written any of that code yet. The biggest thing in query that's different from a Git repository is the data model is set inside of a Git data, inside of a query data set. So you can merge any two data sets. You can compare any two data sets at any given point, because there's no confusion about what file is where. We know exactly what each file is supposed to do, if that makes sense.
And I guess in that case, if I wanted to continue like applying the same transformation again, I would just like create the same script as the one you have to like fetch the data, and I would continue like picking on the source and like applying the transformation.
Yeah, I mean, I can just share really quickly. We have a shortcut for that. We call it recall. So I can do queries save recall TF, and that will just pull the transformation out of my history from one time back. Now, if I wanted to go back 2 transformations, I can recall ~2. So me IPFS node count. This would error because there isn't a transformation 2 histories back. You're thinking, it's a kind of a funny way to think, but you're thinking across the possible versions of a data set. So if I do this, this will, I can't do TF1, obviously. That doesn't work. Oh, right, because my Prometheus server isn't turned on, but recall works. Recall is the thing that under the hood, if we do query update run me IPFS node count, that will do the exact same thing. It's just an alias for recall, the last transform script, because it's so common to do. On that note, do you need custom code how query interacts with your data set? Is it pretty auto-magical? Yeah, so there are 2 really auto-magical parts inside of the transformations. We have something called download and something called transform, which are 2 special functions that you define inside of query. And the signature of download and transform is DS and then a context. And so DS just gives you the last version of the data set. And so you can see, oh, cool, we had this was the body, and I can examine that. And this works really well for append-only logs. So you can say, hey, my data set had these 10 entries, go to the last entry, start the date stamps from there. And then so those 2 functions, if you define them, query calls them for you. And so those are automatically called in the background. But if you define none of them, then nothing will happen because your transform isn't doing anything special, if that makes sense. Does that answer the question? And then, yes. So moving on to Johnny Crunch's, how do you handle semantic interoperability, the meaning of the data between JSON LD? This is a great question, Johnny, that I love digging in on. So our JSON LD support is planned. We currently support DCAT as a raw specification and RDF as export formats. So query has semantic understanding of your data with a couple of caveats, because we have to get a little specific about what the word semantic means. If you have a column that's labeled population, query doesn't know that that's a count of people, right? For that, you would need some sort of specification like RDF or something like JSON LD, where you're actually talking specifically about the same thing. I'm very excited at IPFS Camp to sort of get into a big conversation with the IPLD team about graphing and linking schemas in a way that could be represented as JSON LD. But I think that's an area of future research for us. But at a base layer, what query can do for you out of the box is it understands what you're talking about when you say data set. So if you say combine these 2 data sets, it can smash all of those rows together for you. or I can smash all the metadata together for you, or you can grab all of the titles of all of your data sets. That's all doable. But what we want to get to is for query to understand that when I say population, I'm talking about a count of people. And that's a big, long conversation where we're mapping things that humans care about onto things that machines know, which is a big, messy problem. And then finally, are you working with governments in their open data initiatives? Yes, we work with governments a lot, particularly in New York. We have a lot of great, very productive conversations here with the city of New York, which has been a great partner. We're also working a bunch at the sort of global, international level on the UN's Sustainable Development Goals, which is also another source of majorly stale data that we work on a bunch. And also through my work at the Environmental Data and Governance Initiative, we work a lot on archiving climate data, which is also another sort of like sector that tends to get stale and tends to be difficult to sort of like keep your sort of finger on the pulse of. So we do, I think the people who gravitate toward query the most early have been mainly in the civic tech sector. We've had a lot of interest from that side.
Thanks. I'd like to add that warms my heart that you're working with New York City open data, because I know for years they've had a problem with like data that's old and data that's outdated. So honestly, kudos to the wonderful work that you're doing.
No, thank you. Yeah, they're actually really excited about it because there's a real desire to make this a two-way conversation, right? If we think about data portals, they're sort of this one-way dissemination of data that is often stale. And it's very difficult for as an individual citizen to come in and say, I want to help. I want to sort of improve your data dictionary, or I want to make some changes to the data that I know is incorrect. And there's no method to have that dialogue right now. And so a number of places that we're very excited is someone can make an auditable upgrade, right? I can take that data, prove that exactly what I changed is this stuff and only this stuff. We didn't really get into queries diffing tools today, but we have a giant differ that allows you to diff structured data. And I can sort of show you, hey, this is what I want to change. And that sets up a conversation where a data maintainer inside of a city who is overly burdened with their work already in the sort of civic sector is able to actually accept that enhancement. Whew, okay, that's a lot. I think we covered. It kind of went all over the place there.
That's great. This is wonderful. Are there any more questions?
There are a couple I think didn't get answered yet. One on identity, how to manage identity, and the other one was about
Cura.
I think about
CORS, right? Yeah, and can I use Cura as an API for custom data visualizations on IPFS website? Basically, what is the CORS?
Yes.
Basically,
totally.
Kind of make like a fancy nodes dashboard.
Yes, you can totally make a fancy nodes dashboard. So everything you're seeing on the front end is leveraging a JSON API, which is available when you run Query Connect. So that's locally available. We don't make a like hosted version of that available because we really want you to use the distributed tools. But so that's totally possible. And I shouldn't be talking about this yet, but we're inches from GraphQL, sort of like looking like it's a possibility. It's going to take us like 6 months, but we think that you will be able to turn the entire query network into a GraphQL thing, which would be fun. Getting to identity and management of identity and private data sets, which I think are sort of hand in hand. Those are the sort of like really what constitutes our goals for the next 8 months to a year. We're going to do a very serious look at access control, including a lot of cutting edge work around differential privacy, which will allow certain individuals to say, I would like an anonymized version of this data set, which to us is a very important sort of thing to be talking about when we're thinking about access control in relation to data. And we'd like all of that to happen on cryptographic primitives that are sort of based in decentralized identifiers. And so this is sort of taking the DID spec, layering on an access control system that is ideally sort of like more generic than just dealing with query problems, but leaves us space for doing stuff like I would like an anonymized version of this data set. It's an area of major league active research. What we have today is you provision just a basic cryptographic key pair that almost exactly resembles your peer ID. So you have a public-private key pair, and that's how we manage identity on query for now. Does that make sense? Yeah, when you read the process of setting up a query node is you just run query setup, and that provisions 2 key pairs and make sure you have an IPFS repo. Then it makes sure you have, and then it makes you a query key pair. And when you choose a peer name, we just register the public key with the registry and say, cool, can you prove this? And then there's a simple proving ceremony, and then you can claim an identifier. And then we make sure you can't claim too many in an hour. that's about it. But awesome. Thank you so much for listening, everyone. Does anyone have any other questions? No question is too. This is a fun crowd because we all know IPFS, so we can sort of talk very technically. But then Query is very much aimed at folks who don't know IPFS and spend a lot of time just working with data, and so it sort of can shift very quickly between two conversations.
Well, Brendan, thank you so much for taking the time out to explain the wonderful work that Query is doing.
All right, thank you very much for listening.
And you'll be at IPFS camp, correct?
I will be at IPFS camp. I'm very excited to share a lot of what I've just shown you, sort of the guts under the hood, are some things that we're really hoping to sort of port back into the IPFS community. Yeah, we're really looking forward to many chats at IPFS camp. Just generally excited.
That's awesome. We can't wait to learn more. And thank you once again. Thank you very much for taking the time out to explain Query and the wonderful work that you're doing. And for everyone else, for the IPFS weekly meeting, we are not going to have a weekly meeting next week and a week after because of IPFS camp, but we will continue again, I believe, the beginning of July. So thank you very much. I will put out an issue about this, and I will see everyone in the future, the next July. Thank you. Take care. Goodbye. This upcoming July.